Hey guys, this is Mark Harian, and this video is on dimensional analysis. In the notes on dimensional analysis for my class, the video in those notes is one way of doing it. This is the way that I actually taught in the notes that I'm going to show you in this video. Just for those that are gone or need review and some practice, you can watch this. So we're going to do dimensional analysis for metric units. So just remember, when you guys are doing this, keep in mind the King Henry thing, because that'll really help when you guys are having to remember what each thing means. So remember, the King stands for kilo. That means 1,000 times bigger than the unit. Okay. Hecto is 100 times bigger, and deca is 10 times bigger. The base units, which are meter, liter, and gram, we consider like a factor of one, okay, for that, or 1 unit. As you go towards the right of the base unit, everything's getting smaller. So deci is 10 times smaller, centi is 100 times smaller, and milli is 1,000 times smaller. So in this method, we're going to use those numbers in the rate for dimensional analysis. So what is dimensional analysis is the question that we need to address first. So dimensional analysis, we have some definitions. We talked about this in class, but just to review, we have the given amount, which is what's given to you in the problem. Okay, and that has 1 unit, whether it's grams, liters, milliliters, kilograms, whatever. That only has 1 unit attached to the number. Okay. The rate has 2 units, and that's what we call the conversion ratio, or the factor, or however you may hear it in different videos you watch on this. In my class, we call it the rate. Some classes call it the factor, or some call it the conversion ratio. Okay. So when we look at this example, this would be a way to convert my age in years, which is 48, to days, okay, using dimensional analysis. So I have 48 years. That's going to be the given amount. So the question would say, hey, how many days is 48 years? Or convert 48 years to days could be a question. But that's always going to go on the top left. Now, real quick, what is technically on the bottom is a 1, but we don't usually write the 1 in chemistry when we're showing the work. If you have to or want to, you can. You don't need to do that to show the work. Then you see the multiply sign, and you see here 365 days. Well, the question would be, how many days is this? So whatever is desired, in this case, the answer wants it in days, that goes in the top right. Okay. What goes on the bottom of the rate, or the factor, or the conversion ratio is the unit that we need to cancel. So in this case, years need to cancel out. Okay. We need to get rid of years, and we need to go to days. So on the top is what I'm going to, on the bottom is what I'm getting rid of. And so that's usually going to end up in a diagonal there, and we get those to cancel out. In the calculator, it's really easy. It's 48 times 365. It's technically divided by 1, but I'm not going to waste my life dividing by 1 or multiplying by 1 ever. Okay. So 48 times 365 in the calculator, you get 17,520 days. So when I turned 48 last October, right at that moment, I was 17,520 days old. Okay, for that. So that's the general setup: given amount, rate. Okay. So let's move on. Let's look at the steps for dimensional analysis. This is review from my class, or if you're learning how to do this in somebody else's class, these are the steps that I give my students. So 1 is to write the given amount in the top left. 2 is to write the rate, so the units cancel. 3 is to put a 1 next to the larger unit. And that's why I go back to King Henry died unusually drinking chocolate milk, because that gives me the lineup from biggest to smallest, so I can tell who's bigger and who's smaller when it comes to units. Number 4 is put the meaning of the prefix in the other spot. Okay, so if milli is 1,000, I would put 1,000 in the other spot. We'll look at that in just a second in some examples. I multiply across the top of the dimensional analysis setup, and then I divide by the bottom number. If it's a 1 in the bottom, don't waste your time. Okay. And the last thing I do is hit equal. Okay. So let's look at how to set up this one. It says convert 30 liters to milliliters. So what I'm going to do is follow these steps. So the first step, write the given amount in the top left. So that's going to be 30 liters in the top left. Okay. Second step, write your rate so the units cancel. So the rate for metric comes from the King Henry thing. I need to get liters to cancel. So liters need to go in the bottom right because liters are in the top left. Those two will cancel out. We want to put milliliters in the top right because that's the desired unit. Okay. So my next move is to put a 1 next to the larger unit. Well, looking at King Henry, we have King Henry died unusually drinking chocolate milk. Milli is here. The base unit liter is here. This is the bigger side. These guys are smaller. So liter is bigger than milliliter. So I put a 1, like it says here, put a 1 next to the larger unit. Step 4 says put the meaning of the prefix in the other spot. Well, I know milli from memory means 1,000. It's 1,000 times smaller, so I just put the 1,000 there. Okay. So then I multiply across. It's 30 times 1,000. Most of you guys can do that in your head. It's 30,000. And you end up with milliliters. Okay. Divide by the bottom. I'm not going to do that because in this case it's a 1. So I just forget that. And then when I hit equal, I should get 30,000 milliliters. Okay. So it's a really easy way to convert metric units and show your work so that a teacher such as myself would know that you know what you're doing. Okay. Without Googling it, without just using this. And we teach you this method for later in the year because we start converting things that are probably easier to deal with, but it'll really help to have this type of setup down for what we do second semester in Honors Chem and Chem. Okay, so let's look at an example. This one says convert 505 centigrams to grams. Okay, so first step, put your given amount in the top left. So I set it up like this and do that. Second step, set up the units for the rate so that the stuff that needs to cancel out cancels out. Whatever is up here needs to go down here. And whatever I'm trying to find always goes in the top right. The desired unit always goes there. The one we're trying to get rid of always goes in the bottom. Okay. Next thing I need to ask myself is which one's bigger? So again, having this memorized really helps. So when I look at this, I'm comparing centigrams, which are here, to the base unit, which is grams there. So centigrams are smaller, grams are bigger. So grams, I put the 1 next to the bigger one. Okay. Centi means 100 times smaller, so the meaning goes there. So now in the calculator, it's 505. I multiply across the top. That's times 1. Don't waste your life doing that. The next step is to divide. So I'm going to divide by 100 in this case. So 505 divided by 100 gives me 5.05 grams. So 505 centigrams is 5.05 grams. And by the way, when you're doing these for metric conversions, you should have the same digits involved in the answer. The only thing we're doing is moving the decimal point. Okay. And when I showed you the easy way with this, you could see the decimal point moving, but that's really all that's happening. I shouldn't have 505 here and then get an answer like 12,897. That is not how the metric system works. It's got to be same digits, but different powers of 10 for the metric system. We will do stuff later in the year where it doesn't work out that way, but for metrics based on tens, really easy to deal with. Now, let's say you come up against a problem that's 2 steps, and you can tell by looking at the problem. I'm going to give you this example here, and we'll talk about it. But you notice here, this one says convert 3,150 millimeters to kilometers. Both of those have a prefix in front. They're both some form of the meter, but they both have the prefix. The last problem we did, there was one of them didn't have a prefix unit. We had the base unit. So there's a couple ways of looking at it. If the base unit is not involved, it's 2 steps. okay? Or if both of them have a prefix, which means the base unit is not involved, it's 2 steps, okay? So 2-step problems in the metric system, that's as much as you'll see in the metric system as a 2-stepper. And so let's look at this portion here. It says in a 2-step problem, always go to the base unit first. In this case, it's meters, okay? Then convert to the desired unit, which would be kilometers. So let me show you this problem, and we'll look at it and do it together here. So we have step 1 is always put the given amount first. That's given. So millimeters there. Now, when it says 2 steps, that means you have to multiply twice, okay? So by 2 factors or 2 rates. So I'm always going to go first to the base unit. Well, the base unit for millimeter and kilometer is meter, which you probably guessed. And then we go to the desired unit, which in this case is kilometer or kilometer, okay? So that's where I'm going. First leg of the trip is millimeters to meters. Second leg of the trip is to kilometers. Okay, so it's just like stopping on the way to Disneyland. We stop in Bakersfield or somewhere in the middle, usually, okay, or somewhere there. Next, I need to put the cancellation units in. So I've got millimeters there, millimeters there. I have meters here, meters there. Okay, notice I haven't put a single number in this thing besides the given. Then I ask myself between these two, which is bigger? Using the King Henry thing, the meter is bigger, and milli means 1,000 times smaller. So I'll put that in, okay? Then we look at these two, kilometer is bigger, so I put a 1 next to that, and meters, kilo means 1,000, so the meaning of that prefix will go there. So once you identify, put the 1 next to the bigger one, the other one gets the meaning of the prefix involved, okay? Now, the calculator, you got to be careful on this. There's a couple of ways to put it in. You can put 3150. It's times 1 times 1. Don't waste your life. Then I start dividing. So one way is to divide by 1,000, then divide by 1,000 again. Okay. The other way is to go 3,150 in the calculator, hit divide, put a parentheses, 1,000 times 1,000. Remember, the calculator is dumb and it will do whatever you tell it to do. What you don't want to do in this is go 3,150, hit divide 1,000, and then without parentheses do that, because that's going to kick this 1,000 up to the top in the calculator, and you're going to end up with those cancels. You're going to get 3,150 as an answer if you do that, which is absolutely wrong. It's not going to be the same thing in kilometers that it is in millimeters. Okay. So when you're doing this one, we have 3,150 and you get 0.00315. Again, it's the same digits. It's just the decimals moving, and that's going to be in kilometers. And this one, you'll get the same exact thing if you put it in there. Okay. So either of these are acceptable. This is garbage and will mess you up. Okay. So know how to use your calculator when you guys are doing these. So those are examples of 1 and 2-step metric conversion problems. That's as tough as they get for the metric system. And it's the preferred way of showing how to do these problems on a test or homework and things like that.